Energy units, we use two of them. A joule, named after this guy named James Joule, and he was the guy that came up with these energy units. And we also probably have heard about this one before, a calorie. So the conversion factor between a little calorie and a joule is 1 calorie is equal to 4.18 joules. Obviously, a calorie is about 4 times larger than a joule. Joule is a very small amount of energy. Okay? Now, on a food label, you see big calories. And a big calorie is equal to 1,000 little calories. Okay? And this right here is equivalent to that. Okay? So, a food calorie is 1,000 little calories. So, therefore, don't get those confused. Alright, so here is an example of what happens in a reaction where there's a change in energy. So you have a system, which is where the reaction is taking place, and then you also have the surroundings, and the surroundings surround the system. Okay? Now, if energy is released into the surroundings, okay, this means that our delta E is going to be negative. This means that it's exothermic. Okay? Now, if energy goes into the system from the surroundings, okay, so that means it's gaining energy, right? The other one means it's losing energy. That's the reason why it's negative. Okay? This one means it's gaining energy. This means that it's endothermic. Alright, now there's this other term called enthalpy. Enthalpy is the amount, okay, so there's a quantity. There's the amount of heat energy possessed by substances. Okay, so again, just like we did the delta E, now we're going to use delta H. Delta H is changes in enthalpy. Okay, and we have a final, and we also have an initial amount. And if we have an exothermic reaction where the enthalpy changes are negative, heat flows out of the system into the surroundings. Okay? So therefore you're going to have a negative value. Okay? Now on a chemical equation, if you see this value in kilojoules, which is a unit of energy, right? Because it's just a kilojoule or 1,000 joules. If you see it on the product side, that means that energy is a product. Therefore, it's leaving the reaction and going into the surroundings. So that's when you can see or tell if it's exothermic. Endothermic reactions are those in which heat is added, okay, or flows into the system. Enthalpy changes has a positive value. So if you take a look on an equation, okay, if you see a delta H that's positive, you know it's endothermic. And if you see it on the reactant side, okay, where it's being added to the reactants, that means it's endothermic as well. Now take a look at this above equation. N2 plus O2 makes nitrogen monoxide. Now why is it a good thing that the above reaction requires energy, which means that in order to get this reaction going, you need to apply 43 kilocalories, which is the same as 1,000 big cals, or actually, I take that back. This is equivalent to, sorry, 4,300 little cows. Which is equal to 43 big cows. Okay? So a big cow is the same as saying a kilocow, which is the same as saying 4,300 small cows. Sorry it's so confusing and they use all these units that we basically assume that you understand, but just take a look at it and you'll understand it. A K-cow is the same thing as a big cow, which is the same thing as 1,000 little cows. Okay? So take a look here. Why is it a good thing for the above reaction? Requires some energy. Well, the reason being is because both of these are in our atmosphere. And if this was an exothermic reaction, this would be mostly in our atmosphere, which is very, very poisonous. Okay? All right, now taking a look here, what happens in an endothermic reaction? Well, here's an example of one. We'll probably do this one in class. Okay, notice how you can see energy on the reactant side. When we do this, what happens is when we react these two substances, this thing right here gets very cold, hence it actually freezes this wood block onto it, okay, holding it in place. Okay? An endothermic reaction basically takes the heat from the outside and brings it in. This is the reason why they feel cold, because what's happening in an endothermic reaction is it's feeling cold is because it's removing the heat from your hands and putting it into the system. Alright, so enthalpy change for a reaction is equal to the magnitude, which is the size, but opposite in sign to delta H for the reverse reaction. So what does this mean? Okay, so the enthalpy changes for a reaction depends on the states of the reactants and the products. If we take a look here, here are two reactions, just one going in the reverse. This one going in this direction is positive, which means it's endothermic. But if we take a look here, and we just reverse it, okay, which is what this is saying here, okay, it's still the same size, but it's equal in magnitude, which means it's exothermic. You're still going to get the same amount of energy going in or out, but it just depends on what direction the equation is moving. As you can see here on the energy diagram, this will be an example of a forward reaction going in this direction, and obviously we're starting here and we're going down, which means it's negative in sign. But what if we reversed the reaction and went in this direction, where this was now our reactants and this now is our products? If we go in this direction, which it can, we go up in energy, and now we're endothermic rather than exo.